Okay, we start, please. If you have two binary digits, x and y, and you need to add them, you will start with the following cases. So if you have 0, 0, the sum is a 0 and the carry is a 0. If you have 0 plus 1, so you are adding two digits, the sum will be 1 and the carry is a 0. We have a carry if we exceed 1. So 1 plus 0, you have a 1 and the carry is 0. We still did not exceed 1. Now 1, 1, we have 2, so we exceeded the 1. So the sum will be 0 and the carry will be 1. So we check the following cases. Here you have also a 0, 0, but the carry is a 1. So what do you do? It is a 1, carry 0. How about here? It is 0 plus 1, and the carry is 1. So you have 0, 1. How about when you have 1, 0, and the carry is 1, so it is a total of 2, so 0, carry 1. And the last case will be 1, 1, and you have a carry. This will give you a 3, so it is the sum is 1, and the carry is 1. So these are all the cases where you have a single bit binary addition with a carry of 0 and with a carry of 1. Let's do an example where you are adding multiple bits. Okay, we start with the first part. Assume you have 0, 0. Who can help, guys? Jad, can you help? Okay, so
I am sorry, but I'm new, so I am.
Okay, yes, I remember. Sorry, I shouldn't have asked you. Yara?
Yes, I'm very sorry.
Yara, can you help? So what are we doing? We are adding 0 plus 1. Of course, the first carry is always a 0, okay? Because this is our first bit that we are adding. And
Yes.
so this is 0, 1. So what is the sum? It's 1.
Yes.
Carry 0.
But-
يلا you keep going, please.
1 1 في عندي بيكون جواب 0 عندي carry 1.
So it said 2. So 0, carry 1. Now 1, 1, 1. What do you have?
عندي 1 1 يعني بيكون الجواب 0 carry 1 بس لأنه في 1 فوق بتصير 1 carry 1.
Exactly. So you have a total of 3. So it's going to be a 1, carry 1. Okay, we continue. 1 plus 0
1
plus 0. It is?
carry 0.
It is 1. 1 plus 0 plus 0 is a 1.
Yes.
And add a carry 0, of course. Now we have 0 plus 1 plus 1. It is a 2. So 0, carry 1, and that's the 1. Okay? We move to another example. Who can help? Sharbil Bukhalil, can you help, please? I am doing the addition of these.
Doctor, I can help.
Yeah, let's try, please. 0
Okay,
plus 1.
0 plus 1 يعني 1.
1 carry 0.
1 carry 0.
So
تاني واحدة 0 plus 0 so equals to 0.
exactly, carry 0.
تاني واحدة 0 plus 1 plus 0 so 1.
1 carry 0. Exactly.
كمان 0 plus 1 plus 0 1 carry 0.
Yes. And
0
0
plus 0 plus 1 is equal to 1.
1 carry 0, exactly, okay? So this is how you do multiple bit binary addition. We move now to, let's say you are doing subtraction. If you are doing subtraction, let's go over the cases. If you subtract 0 from a 0, it's going to be 0, but now we have a borrow, not a carry. So the borrow is a 0. If you are subtracting minus 1 from a 0, we do not have that, okay? So it's going to be 1 and borrow 1. So you need to borrow 1 from the adjacent value digit, okay? So you will get now a 2 and you subtract 1 from it, so you get a 1. You got the idea? It's exactly like when we do in digital subtraction or in decimal subtraction. Okay, when you are subtracting 0 from a 1, it's 1, so no problem. And when you are subtracting 1 from a 1, it is a 0, carry 0. So these are all the cases of subtracting a value out of 0 or a 1. However, if you are subtracting a 0 from a 0, but you have a 1, okay, with a carry, the borrow that you have here comes from a previous subtraction, okay? So this is going to be subtracting a 0 from a 1, so it's the same case that we had here, okay? So it will give you a 1, 1, and this will give you a 0, 1. This will give you a 0, 0 because you are actually subtracting 1 from a 1. And this is subtracting 1 from, you have now 1 plus 1 minus 1. Okay, so this is how you are subtracting. This is easier if you understand how do you do subtraction with more than one value. So we do it here. It makes it much easier. Notice, please. I am subtracting 1 from a 0. I cannot do that. So I borrow from this one. It becomes here 2. 2 minus 1 is a 1. You got the idea? Now here I have a 0 after I did the borrow. Okay, so I borrow from this one. It becomes a 2. 2 minus 1 is a 1. Now, this is a 0 because I borrowed from it. 0 minus 0 is a 0. 1 minus 0 is a 1. And 1 minus 1 is a 0. I'll do another example to make it clearer. I am subtracting 1 minus 0. Is this possible, Elissa? Can I subtract 1 from a 0? Yes, Elissa?
No.
No, we cannot. So what do we need? We need to borrow. When you borrow from here a 1 to here, this becomes a 2. Okay? So what do you do? 1 minus 2 it is. Yes,
Doctor,
Elissa?
but how it becomes a 1? It's a 0. It becomes a 2. It's a 0.
You know, when we are subtracting in decimal and you borrow, okay, because you are subtracting 9 from a 6, can you do that? 9 from a 6? No. So you borrow one value from the adjacent digit. Do you actually borrow a 10 when you borrow one digit? Doesn't the 6 become 16?
Oh, yes.
Yes, you borrow actually a 10 because you are working in decimal. So the 6
Oh,
becomes
okay,
16. In the
Yes,
case of
yes, I get the
binary,
point.
when you borrow 1, you are actually borrowing a 2 because you are working in binary. In hexadecimal, when you borrow a 1 from the adjacent, you are borrowing a 16. You got the idea? Depending on the base you are working on. So here we are working in base 2. So when you borrow, you are borrowing a 2. Clear?
Yes, thank you.
Okay. So we continue, Elissa, you were saying, I
دكتور انا ما
borrowed here a
فهمت
1.
صراحه.
Sorry?
دكتور انا ما فهمت كتير قصه الزيرو وال1 subtracting. I
Okay,
didn't
let's
actually get
repeat.
it. Can you repeat it, please?
Yes, I will. Yeah, now 1 second. I am following this example, okay? So pay attention. You are subtracting 1 minus 0. Can you do that? No. So what do? You borrow from this. It becomes a 0. And this 0 becomes a 2. So 2 minus 1 is a 1. Now I am subtracting 1 from a 0. Can I do that? No. I borrow from this, it becomes a 0, and this 0 this 0 becomes a 2. So 2 minus 1 is a 1. Now 0 minus 0, 0 minus 0 is a 0, 0 minus 0 is a 0, 1 minus 1 is a 0. Is it clearer?
Yes, thank
I
you.
will repeat the first one again, so I make it more clear to you. I need your help, Rabia. Okay, what are we doing? I want to subtract 1. I am doing this one, okay? I want to subtract
Okay.
1 from a 0. Can I do it, please?
Yes, sure. Okay. So what we do is we take the left one and we cross it out. We add a 1 on top of
So
it.
this
So
will
it's a 1
become a
minus 1, so
0,
it's a 0.
and this will
Okay.
become a 2.
Now, yeah. So now it's 1 minus 1. Okay.
It is 1 minus 2.
Okay.
So it is
So
1 minus 2. You get a 1.
okay.
Now, I am borrowing the next one. I am subtracting 1 minus 0. Is this feasible?
1 minus 0, yeah. Oh,
No.
I'm subtracting 0 minus 1. It's not feasible, but 1 minus 0 is yes.
No. So I am asking, can you subtract 1 from a 0? You cannot do that.
No,
So
I can't. So I have to borrow again. So
Again.
now it's a 2 minus
This
minus
becomes
1.
a 2. So
So
yes,
it's a 1.
2 minus 1 is a 1. Keep going.
Yeah, but I
0
have to
minus
borrow
0
it.
is a 0.
Yeah.
1 minus 0 is a 1. 1 minus 1 is a 0. Is it clearer?
Yeah. Thank
Any
you.
question, guys, all of you? I'm ready to repeat if anyone did not understand the borrow. Any question? Okay, I will continue now with the multiplication. So, yes,
Please can you repeat أنا الإنترنت ما كانت عم تجي
yes,
منيح
okay. I am going to repeat, but I will do the last example, okay? So check this, please. I am subtracting 0 from a 0, it's a 0. 1 from a 1, it's a 0. 0 from a 1, it's a 1. We do not have a borrow here. Okay, that's not a nice example. I will repeat the middle one, okay? Because it has a borrow. I want to subtract 1 from a 0. Can I do that? No. Okay, so what do I need? I need to borrow. I borrow from the 1, it becomes a 0, and this 0 becomes a 2. Why did it become a 2? Can anyone help, please? I borrowed a 1. How come it became 2?
Because it's binary.
Thank you, because it is binary. When I am working in Octal, when I borrow a 1, what does it become? In Octal, an 8. In Hex, a 16. In Decimal, 10. Clear? So I am subtracting a 1 minus 2, it's a 1. Again, I want to subtract 1 from a 0, I cannot, so I borrow. I borrow here a 0, it becomes a 0, and this becomes a 2. So 1 minus 2 is a 1, 0 minus 0, it's a 0, 0 minus 0, 0, and 1 minus 1 is a 0. Is it clearer, guys? Now, we do multiplication. Pay attention, please, to multiplication. Multiplication, you have, this is called the multiplicand, this is called the multiplier, and the last answer that you get is the product. I want you to be careful, please, what we are doing, but let me go over these first. 0 times 0 is a 0, 1 times 0 is a 0, 0 times 1 is a 0, and 1 times 1 is a 1. Okay, so no change. We continue now, please. I am going to multiply. We start here. I am multiplying 1 with 1, 0, 1, 1. So 1 times 1, 0, 0, 1, it will remain the same. 1, 0, 1, 1. Now I move to the second digit, which is a 0. When I move to the second digit, okay, I shift left, which means I put here a dash, I'm not adding any value, and I am multiplying now 0 by 1, 0, 1, 1, and I write the answer here. Okay, now I reach the third digit, which is the 1. So this is what I'm multiplying now, and I do a shift left, okay, and I multiply 1 by 1, 0, 1, 1, and I write the answer. Now what do? I draw a line and I add the three answers. I will start now. I am adding 1 plus 0, 0, it's a 1. 1 plus 0, it's a 1. 0 plus 0 plus 1, it's a 1. 1 plus 1, who can help?
The 0, 1 plus 1, here 0 carry 1.
Bravo, it's a 0 and we have a carry 1. Now 1 plus 0 is a 1 and a 1. Okay? Did you understand the multiplication? Let's verify our answer.
I didn't, doctor.
One second. Who can tell me, please, what is this number in decimal? Can anyone tell me, please, what is this number in decimal?
In decimal, هيدي 8 plus 2 plus 1.
Exactly.
11.
So this is 11. And what is this number in decimal, please?
5.
This is number 5. And when we multiply it, we are expecting a 55. You agree? So
Yes.
let's verify our answer, please. Who can help? How do we verify this answer? This is a 1. Yes, please.
2.
2.
4.
4. I don't have an 8.
16.
16.
Yes.
And
32.
32.
Okay. Adding these values up, it will give me 48, right? So 16 and 4 is a 20. And you have 32 is a 52 and a 3, 55, and they are equal. You understand the verification?
Yes.
Okay. So this is multiplication. Do you have any question about multiplication? I am ready to repeat.
Yes,
Doctor, can you-
please, doctor?
Do you want me to repeat the multiplication?
Yes, please.
Yes, we start again, please. I will change this to a pointer, so pay attention. What I am doing, I am multiplying this one by 1011, I get a 1011. Now I shift left, so I am multiplying 0 by 1011. Of course, 0 multiplied by anything is a 0. Then I shift left again, I am getting the 1, and I multiply 1 by 1011, it's 1011. I draw a line and I add these three answers, I get the following. How do I add? It is 1 plus 0, 0, 1. 1 plus 0 is a 1. 0 plus 0 plus 1 is a 1. And 1 plus 0 plus 1 is a 2. So it's going to be 0, carry 1. 1 plus 0, 0 is a 1. And 1 plus 1 is a 1.
Oh, yes, I understand it.
Okay,
Thanks.
so you go one digit at a time. You multiply this digit by the number, this digit by the number, and this digit by the multiplicand. But you have to make sure you shift. If you do not shift, you get a wrong answer. Okay?
Okay, thank you.
على طول zeros.
Yes, this is in binary. When you are multiplying in hexadecimal, okay, you get a different answer. So pay attention now what we are doing. I am adding in hexadecimal. I need your help, guys. What is F in hexadecimal?
Okay.
16.
15. 15, right? Because 15 in hexadecimal is F. Why? Because we start with the letter K to be 10, 11, B, okay, 12 is the C, until we reach the F, which is 15, okay? We start. F is 15. 15 plus 6 is a 21. Do you agree?
Yeah.
Okay.
Yeah.
So 21 is a number that exceeds 16. So what do? It is minus 16. I have a 5. So it's a 5, carry 1. You got the idea? We continue now. 1 plus 9 plus 4. يلا who can help?
دكتور بس فيك تعيد 21 minus 16.
Yes, so you have F is 15 plus 6, it is 21. So 21,
Okay.
you cannot write 21 here. You have to write it in numbers from 1 till F. So I cannot write 21 because the biggest number I could write is the 15. So what do? I write 21 minus the hexadecimal because I am working in base 16. So I subtract 16 from it. I get a 5. So it is a 5 with a carry 1. Now, who can do the second part, please? So 1 plus 9 plus 4, what is it?
14.
It is 14, and 14 is NE, so you simply write it, okay? How about the third one? It is 5 plus, yes, your help? E is 14, plus 5,
18.
it is 19, right? 19 minus 16, it is a 3 and a carry 1.
دكتور بس أول شيء 21 minus 16 أعطينا 5.
Yes,
كتبنا ال 5 وعملنا carry 1.
Yes.
بس مش لأنه ال F 15 ما خص.
It doesn't matter. You check the total. Your total is 21. You subtract from it 16. Check here. Your total is 19. You also subtract from it 16. So you always have whatever is the total to subtract from it 16 because we are working in hexadecimal. If you were working in octal, you would subtract 8. Okay?
لا.
Yes, please.
Why do you have the 1 آخر شيء?
Because
Carry
you
1.
have a 3 and a carry 1. Don't you have here a 5 and a carry 1? Here also you have a 3 and a carry 1. But since it is the last number, you write the 1 next to the 3. If you were to keep going with the addition, 1 will be a carry.
Yes, but I'm not getting why إنه بال5 وبال3 حطينا carry 1.
Yes. Why? Because you have 116.
Okay.
Okay. So we continue, please. I'll show you an example when you do addition in decimal. Check, please. 8 plus 9. 8 plus 9. In decimal. It is 17. Do you agree? How do you write it? You write it 7, carry 1. No? It is exactly the same. But this is in decimal. Okay? Now, I will do octal multiplication, so be careful, please. Octal multiplication means I am working in base 8, so be careful, okay? I will start with the first. Yalla, your help, guys. 5 times 2 is 10. 10 exceeds 8, do you agree? So what should I do?
Yes.
I should do 10 minus
Minus
8 is a 2. So 2
2 carry 1.
carry 1. Now, 5 times 6, it's a 30. Plus 1, 31. Now what? I will ask myself, how many multiples of 8 do I have in the 31? Okay, so I have 8 times 2, 16, 8 times 3, 24, 8 times 4, 32. 32 exceeded 31, so no, I want the number that comes
So
before
3.
it, which is 24. So I am left with a 7. So this is why I write a 7 here. And how many multiples of of 8 did I use? 3. So I have carry 3. Okay, we continue. 5 times 7 is 35. Plus 3, it's
مش دايما
38.
بنعمل minus 8 حسب الرقم.
It depends on the octal. If octal, you go multiples of 8. If hex, you go multiples of 16. Okay? So 38, what is the biggest number or multiple of 8 that you can
52.
reach? Of
4
course,
times
it
8.
is
4
32.
times 8.
Minus
Yes.
52.
I am left with a 6. So it is 6. But what's the carry, guys?
4.
4 times 8.
This is why we
4.
put the carry 4. Okay? Now we will do,
Yes.
we finished the 5. I want to multiply now by the 4. Who got the idea and can explain, please? I want to multiply by 4. Yes?
Yes, I got it.
Yeah, look, can you do it? So we start. 4 times 2. Yes?
It's 8.
Yes.
Yes, it's 8.
8. So we cannot write 8 in octal because the biggest number we could write is 7. Do you agree? So it's going to be 8 minus 8.
Yes.
It's a 0, carry 1. Right? So this is why I write a 0 and I have a carry 1. So 4 times 6. Yes, Maverick, what do you think? 4 times 6? 24. And
It's
1?
24.
25. So you subtract
Yes.
from 24 and the answer is 1. And what is
24.
what is my carry? It is 1 and you have
3.
Yes, so 3. 7 times 4 is 28 plus 3 it is what did we say? 28 plus 3 is 31.
31, sorry.
Okay, so you subtract from it 28 and you are left with 3. So what is the total? So you have 3 as your answer and 4 as your carry. Okay,
Doctor,
now what
how
do you
did
do? But
we-
let me finish the addition and then I'll get your answer, your questions. So now what do you do, please? You have to add. So 2 plus 0 is a 0. 7 plus 0 is a 7, so no problem, we are not exceeding 8. 6 plus 1 is a 7. Here we have 4 plus 7, it's 11. What happens when it is 11? It exceeded 8. So what do? You do 11 minus 8. Okay, so it is going to be 3, and you have carry 1. 1 plus 3 is a 4. Okay, so this is the answer of the multiplication of 762 times 45 in octal, and the answer is 43772 also in octal. Yes, please, your questions. No questions? Okay. So useful base for base conversion, you have here, you are working in exponents. So this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. These you need to memorize them. They make your calculation faster, especially during the exam. Okay? Clear?
لازم نعرف until لل 10 دكتور.
Yes, 10, 2048, يعني هي 2 to the 11. Yes, that will do. Okay, so you could stop here. Okay?
Okay.
It makes it faster for you. Did you notice now when I said How many can you use? You say directly 32 instead of you calculating them. Okay, clear?
Doctor, can you please just go back one slide so I can just see the results? I'm trying to do it myself.
Okay. Clear? So it is 43772. Okay. So when you are converting from decimal to binary, you have two methods. I gave you one method that was you check the biggest power or multiple of 2 that you have and you solve. Okay? So whatever you are, whatever you are working on here, you have common bases that you should be worry about. In binary, the digits you can use are 0 and 1. In octal, the digits you can use are from 0 till 7. In decimal, base 10, you could use from 0 to 9. And in hexadecimal, from 0 to 15, because it is from 0 to 9, and this is your 10, 11, 12, 13, 14, and 15. I want you to notice how we stop here at the 15 because we are base 16. We stop here at 9 because we are base 10. We stop at 7, we are an octal, 8, because we start at the 0. Did you notice that? So you have 8 digits, but we are starting from 0. So any number that exceeds 7 in octal is going to be a carry. Any number that exceeds 9 in decimal will be a carry. Any number that exceeds 15 in hexadecimal will be a carry. Of course, in 2 also. Any number that exceeds 1 will be a carry. Okay? These are good idea to memorize, okay? But when you start practicing, you will know these very quickly, okay? So let's see number 15 example. How do you write number 15 in base 2? It is 1, 1, 1, 1. I have an 8, I have a 4, I have a 2, and I have a 1. Add them up, it will give you a 15. Who can explain this to me, please? How is this 10 in decimal? Yes, please. Anyone?
Yes.
Yes.
So
Yes.
Yes,
That
Carmen,
is
what do
zero.
you say?
8 plus 2.
Yes, it is 8 plus 2. This is for you, Carmen. How do you explain this?
Okay, so you have 2 to the 3, it's an 8. No, 2 to the,
Yes.
yeah, it's an 8. And 2 to the 4.
No, no. You count from 0, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3.
Yes, 2 to the 2 is a 4 plus 8, it's a 12.
It's a 12. Okay? Clear? How come here that 12 in decimal is 1, 4 in base 8? Can anyone explain? How come it is 4, 1? Yes, please.
8.
We group.
Yes, we go as 12 minus 8, it's a
Yes.
4 carry.
Excellent. It's 4 carry 1. You got the idea? Who can explain how is 15 1, 7 in octal?
We
15
group
minus
from
8.
Yes, 15 minus 8, it's a
Carry
7,
1.
and carry 1. You got the idea? Okay.
Yes.
How can you explain to me how is 1, 1, 1, 0 a 0 and an E?
دكتور كان ليه الأوكتل كنا عم نعمل subtraction.
Yes, you were subtracting 8 because the number exceeds 8. 14 exceeds 8. Okay? I repeat my question. How come 14 is 0E in hexadecimal? Did I do
it is
any
less than
subtraction?
16.
14 in hexadecimal is E,
E.
and it comes 0 since it's less than 16.
Exactly. Since it is less than 16, perfect answer. Okay? Clear, guys? Did you understand the conversion between decimal, binary, octal, and
Yes, doctor.
yes, please.
Can you explain number 16 بالأكتل كيف صار عنا carry 2?
You mean 1, 6, right?
Yes.
Okay. So when you are doing 1, 6, can anyone explain, guys?
Yes, I can.
Yes, please.
Yes.
So it's 2 multiple of 8, so it's 16. It's 0 carry 2.
No. She's asking, how did the 14 in decimal become 1, 6 in octal?
Actually no, I was asking عن ال 16 كيف صارت 20 تحت آخر
Okay,
واحدة.
okay, sorry, you were answering right. Can you repeat your answer, please? My bad. Can you repeat?
Yes, so octal it's multiple of 8.
Exactly.
So 16 is 2 multiple of 8.
Exactly.
So it's 0 carry 2.
So it is a 0 and you have 2 8s in it. So this is carry 2.
Oh, okay, thank you.
Clear?
Yes, clear, thank you.
Any other question, guys? Okay, we continue. Method 2 that you should understand how to convert in bases. We did method 1. You convert the integer part, then you convert the fraction part, and then you join the two results together, depending on the base you are working on. Okay, so we start now with an example. Be careful. I am doing 46.6875 in decimal, and I want to convert it to base 2. So how would you convert 46 to base 2? There are two ways of doing it. Do you remember what are the ways, please? 46. How did it become 0, 1, 1, 1, 0, 1? Yes, guys.
We got the biggest multiple of 2 and remove
Exactly.
it from 46.
Exactly. So it is 46 minus 32. Okay, and you keep on subtracting and you get this answer, right? This is method 1. Who can tell me what is method 2?
We divide by 2 and
Perfect. You keep
check the
dividing
remainder.
by 46 by 2. So 46 by 2 will give you 23, remainder 1. Then 23 by, you keep on dividing until you reach a remainder of 0 and you write this, okay? You need to understand now how do we do the decimal part. We did not do that. Okay, so what is the integral part? It is 46. What is the decimal part? It is 0.6875. I want you to understand that you divide the 46 by 2, but you multiply the 0.6875 by 2. You see the difference? So the decimal part, you have to multiply by 2. Okay, we start. 0.6875, you multiply it by 2, you get 1.375. What do you do with that? You take the 1, you write it here, and you take only the decimal part. So here we go. 0.3750, you multiply it by 2. It's going to be 0.75. Anyone here? No, we have a 0. So we write a 0, and we take again the 0.75 here and multiply it by 2, we get 1.5. What do I do now, please? I got 1.5. What do I do?
I take the 1.
I write the 1 here. I am left with the 0.5. I multiply it by 2. I got a 1 and 0.000. So end of multiplication. I write the 1 here. Now, how do I write the answer? I go with the answer downward. So be careful, please. I go in this direction. So 1011. Okay. So this is the 46. I write it here. And this is the decimal part, which is 0.6875. I write it here. So this is now in base 10, and the second conversion is in base 2. Clear? So how many times do you have to multiply? When do you stop?
When it becomes 0.
Yes, when the decimal part becomes 0. Okay? So the fractional part, you have to specify sometimes that it does not become 0. Okay? So it keeps on repetitive, see? So what do? You have fractional part, it begins repeating every 4 steps. So 1 0 1 0 0 1 1 0 0 1 0 0. See, it is, we are getting a repetition forever of 1 0 1 1 1 0 1 1. So what do you do now? You have to decide to stop after, let's say, 5 decimal places, 4 decimal places, and you truncate the answer. You got the idea? Because sometimes the decimal does not stop, okay? So you have to decide when do you want to stop the repeated multiplications, and you truncate your answer. Now, how do you check the conversion? I want someone to help me, please. How do I double check that this answer that I got is 46.06875? Yalla, who can help? Anyone, guys?
So
I'll have.
0.
Yes, please. Yes, Elisa?
Okay, we have 0 to the power of 2, it's 0. Then
So
we
you
have,
started from here, young lady?
yes,
Okay. So we usually, as a rule, start from here. Okay?
oh, okay.
Okay. So how do you decide which power to multiply? You do, yes, please, you help.
Okay, it's
You
here,
count.
it's,
You count 0, 1, 2, 3, 4, 5. So this is multiplied by 2 to the 5, right?
yes.
Yes, continue, please.
2 to the 5 is 32.
Exactly.
So it's 1 times 32.
Yes.
Yes.
And you have
And then we have
times 8.
2 to the power of 3, it's 8.
Yes, times 4.
And 2 to the power of 2 is 4. And then 2 to the power of 1 is 2. And
Exactly, and the
then 2 to the power
0
of 0 is
you
0.
don't need, and you add them up, you get a 46. So this is how
Yes.
you check the conversion. Okay, I checked the decimal part. Now how do I check I checked the whole part. Now how do you check the decimal part? What is this value after the dot? It is 2 to the
minus 1.
minus 1, 2
Minus
to the
1.
minus 2, 2 to the minus 3, 2 to the minus 4. So here we go, we
Yes.
add them up and we get this decimal and our answer is verified. Okay? Now, how do you repeated division and multiplication work? How come? When you divide the integer portion of the power by the base, depending if what base you are working to convert, you are going to convert. It could be base 2, you multiply by 2. Base 8, you multiply by 8. Base 16, you multiply by 16. Okay? So you divide the integer portion, you multiply the fractional portion. Is the idea clear? In octal, you have 3 digits. We agreed, moving from octal to binary, you have to take 3 digits. From binary to octal, you also group your answer into 3 bits. So let's work on this example. Who can help? Yes, Eli, can you please help? How do I convert from octal to binary? Where do you start from? Okay, anyone else?
Yes.
Yes.
I'll begin with the integer portion.
Okay, which is 635.
635.
Right? Exactly.
Yes.
You need to start with the 6 or with the 5?
5.
5. We always start from the dot. Okay? So how do you convert the 5 from octal to binary? How many bits is it?
It is
3 bits.
yes.
Yes. So 5
I
would
group
become 101. Can you tell me how come it is 101?
4 plus 1.
Exactly. Now 3 will become
2 plus
01.
1.
How come?
2 plus 1.
Bravo. How about the 6? It will become 110.
4 plus 2.
Exactly. We move now to the dot. You write the dot. And the 1 will become 001. Can you explain the 7?
Because it is less than 8 and it is 4 plus 2 plus 1.
Oh, exactly. And again 7. So what did we do,
Yes.
please? We converted from octal to binary. The question now, you want to convert to hexadecimal. In hexadecimal, how many values do I take? How many digits do I take? It's going to be 4 digits. You have to be careful here that if you don't start from the dot, you will get a wrong answer. So be careful. I start from the dot, I take 4 digits, another 4 digits, and then 4 digits. But here I don't have 4. What do? I add zeros to it until it becomes 4. And what do I do here in this direction? Yes, please. How do I start? Do I start from 1100 or from the 5? Yani 101? I start from the dot. So this
Yes.
is the first, this is the second, and this is the third, and I also add zeros to it to make it 4 digits. Now, after you regrouped, you start by converting, taking 4 digits to write them in hexadecimal. So this is a 3, this is an F, and this is an 8, right? Can you explain how this is a D? Yes?
It is 8
8
plus 4 plus 1.
Exactly. Okay, how about this? It's a 9, and this is a... Did you get the conversion from octal to hex? We can never do that, go directly from octal to hex. You have to go from octal to binary, then binary to hex. So binary is considered an intermediate step. Okay? Is the idea clear? You cannot go from octal, I repeat myself, to hex. It has to go through binary. Clear? Okay, we start now with decimal codes. By decimal codes, I mean you have binary system. It is the most natural for a computer. It's the binary. We use zeros and ones. Okay, so this is the 0, 0, 0, 1, and the 1, 0, and the 1, 1. Okay, we can convert decimal numbers to binary. We can perform all the arithmetics and the calculations in binary and then convert our result back to decimal. Okay. But there are other types of code that we could use. I will give an example. What we are talking about now is called binary coded decimal. So be careful, please. We start with the number 0. How many digits are we using? We are using 4 digits. So 0 is a 0, 0, 0. Of course, 5, it's going to be 0, 1, 0, 1. And the 9 will be 1, 0, 0, 1. So where did we stop? We stopped at the 9 in binary coded decimal. Any number that exceeds 9, I mean from 10 to 15, is not defined. We don't have a value for it. Okay? So I want you to look now at the 396 and convert this to BCD. 6 will be 0, 1, 1, 0. 9 will be 1, 0, 0, 1. And 3 will be 0, 0, 1, 1. What do you think is a problem with BCD? Now, what are you seeing as a problem?
Waste of space.
You mean you are using more digits, right? Okay, because this 6, if you want to think about it, it's 110, no need for this, right? But this is binary coded decimal. This is not conversion. I want you to be careful, please. The difference between BCD and binary, notice, please. 1 will become 0001, and the 8 will become 1000, and the 5 will become 0101. Okay? What we are doing now, I got BCD. How many digits did I have to represent it? 12 bits. But the equivalent binary to represent the 185 in binary by keep dividing 185 by 2 and you get the answer, or you find the biggest power of 2, it's the same. This is the 185. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, you got the idea? So how many bits are used here? It's 8. How many bits are used here? It is 12. So this is the difference between using BCD and binary. Okay, when you represent them, notice please, you are using 2 digits for the binary, whereas in BCD you are using 4 digits. Okay, we made that clear in the example. Okay, how come after the 9, which is 1001, I just told you that the 10 till the 15, we refer to them as invalid, right? So these are invalid values. We will call them later, don't care. But for now, they are called invalid code words, okay? How do you convert? Pay attention. I am giving another example just for you to understand the difference between conversion or coding. BCD is coding. Conversion is you are actually converting from one base to another. So we start with the 1, 3, which is in decimal number 13. How do you write it in binary? I have an 8, I have a 4, and I have a 1. It is the 13. This is called conversion. When I am working in binary coded decimal, 3 will become 0011, 1 will become 0001. You got the difference, please, between conversion and coding? Okay, and again, I have less bits in conversion than in coding. Now, you need to know that I can do arithmetic encoding in BCD. I can also add in BCD. So what I will do now, you need to understand that any number that exceeds 9, I have to add to it a 6, okay? And so I can continue with the addition. Where did the number 6 come from? We are working in decimal, and if I do modulo 6, when dividing, okay, so 10, okay, so 16, subtract 10 from it, you get a 6. So this is why we are adding a 6 every time the number is greater than 9. Let me do an example so you understand better. Okay, I am adding now two numbers that are in BCD. So be careful, please. I am adding 1897 and 2905. Any problem with the conversion, or you got the idea? This is a 1897. Can you see it, or you want me to repeat how did we get these values? 897. And
Repeat,
what about
please.
this? This is a 2. What's this, please?
A 9.
9,
Carry 1.
0,
0,
and
5.
5. Clear? Okay, let's add. It is simple addition, no problem. And how do we add? We start. 1 plus 1, it's a 2, so 0 carry 1. 1 plus 1, it's a 2, so 0 carry 1. 1 plus 1 plus 1, it's a 1 carry 1, and a 1. Now, I look at this value. Is it greater than 9? What do you think? It is 12. So 12 is greater than 9. I add 6 to it, okay? And I get a 2 carry 1. Now this one is added to these. I get 1010. Is this value greater than 9? Yes, please? Let's say
Yes.
10. So yes, it is greater than 9. I add 6 to it. Okay? So 0 plus 0, it's a 0. 1 plus 1, it's a 0, carry 1. 1 plus 1, it's a 0, carry 1. 1 plus 1, it's a 0. I have a carry. What happens to this carry? It comes here. Now I add here again, and I get here 0, 1, 0, 0 with a carry. This carry will come here. And by looking at this number only, be careful to this common mistake students do. It is a 2. So you will say, no, this is not greater than 9. But be careful, you have a carry. So it's already greater than 9. So what do? You have to add also a 6 to it, okay? And you get this answer. And now you add these values and you get this answer. I want you to double check that this is a 4, 8, 0, 2. By adding these two numbers, we also get 4, 8, 0, 2. Okay? So we have now binary coded decimal. You already know decimal. This is BCD. Who can try and tell me what is excess 3? And I am adding 3. So every time you write number 0, it's not going to be 0, it will be 3. What do you think 6 will be? Yes, please? If you add 3 to it, it will become a 9. Add 3 to the 9, it will become a 12. Okay, how about this? This is nice. It is 8, 4, minus 2, minus 1. If you already notice, we usually have 8, 4, 2, 1. But this is another code. It is 8, 4, minus 2, minus 1. I want you to look at this, please. How is this number 5? Be careful. I have a minus 1, I have a minus 2, and I have a plus 8. So 8 minus 3 is a 5. You got the idea? Can anyone tell me how is this 7? Yes, please.
Yes,
I have a,
Okay,
yes,
a minus
I
1,
have a minus 1,
then plus 8.
plus 8, so
So
it's
it
a
becomes
7.
7.
How is this 2, please?
You have a minus 2
I have a
and a
minus
plus
1.
4.
No, I don't have a minus 1. I have a minus 2 and a plus
and
4.
the plus
This will
4,
give
so
me
it
a 2.
becomes 2.
Yes, you are right. Okay, we have many codes. American Standard Code for Information Interchange is called ASCII, which represent 128 characters. They changed it later to 8 bits or ASCII 8, and it was also referred to as 256 characters. Okay, all the printing characters on the computer, like the backspace, the carriage return, the enter, the dash, all of these, they have an ASCII code representation. ASCII has some interesting properties. It starts from 0 to 9, and then you have also all the letters, lowercase, the uppercase, and we have a single unit for 8-bit. But when you are writing characters in Chinese or in foreign languages, 6 bits is not enough, so they went to what we call a Unicode. Okay, Unicode extends ASCII to 65,536 universal characters, where it uses 2 bytes instead of 1. We had 8-bit in ASCII, but here you have 2 bytes or 16 bits. Okay, so this is chapter 1, sorry. I will stop recording.